Hello everyone, welcome back to course Environmental Engineering. As we are discussing about various population forecasting methods, so far we discussed a few methods in this population forecast, and those are arithmetical increase method, geometrical increase method, incremental increase method, graphical method, and comparative graphical method. As of now, we discussed it. In the present, in this particular lecture, I'm going to discuss about decreasing rate of method, master plan method, and as well as logistic curve method. In addition to this, I'm also going to discuss about ratio method, ratio method, and then and demographical method. This one. So first time I will start with this demographic method. This method is also called as a growth composition analysis method. This particular method also called as a growth composition analysis method. So in this method, in order to estimate the population forecast for the design period, in this particular method, we supposed to consider increases population increases due to the death and population decreases due to the death and increase or decrease due to the migration and increase or due to increase or maybe a decrease due to the annexation. So in the actually this is very typical to collect the data. So any government or any organizing body, if we maintain these records, the year wise or for every 2 years, for every 1 year, if they maintain these records, so then it is possible to estimate the population using this method. Otherwise, it is very difficult to method. So coming to the another method is called decreasing rate of method. So here the decreasing rate of growth method is nothing but, so in this particular method, the average decrease in percentage increase is worked out first thing. So the average decreases in the percentage increase is worked out. For example, if you take any two successive decays, first we supposed to calculate what is the average decrease in the decrease and increase in their between their percentages. The population percentage increases between those two successive decays. So it should be worked out first. Then it has to be subtracted from the latest percentage increase. Latest one is nothing but, for example, if you are calculating for 2011, the latest one become 2001. Suppose if you are doing this calculation population forecasting for 2021, the latest one is 2011. So in this way, first we need to calculate the average decrease in the percentage increase. Average decrease in the percentage increase, nothing but here we supposed to calculate the percentages between percentage of increase between the two decays, and then from that we need to be worked out. We need to be get calculate average of decrease between those obtained percentages from two successive decays. So then after, it has to be subtracted from the past percentage increase for each successive decay to get the percentage increase in the for the next decade. So this has to be done. So if you take some problem, then we'll get some better understanding in this way. So the decreasing rate growth method is reaching towards the saturation only because it is valid. It is valid when the growth rate of the particular city or particular town, when the trend of the growth of that particular city downward pattern. So if you from the past few decades, if the trend of the city or town or country, if the growth rate in terms of population of that particular city or town, if the curve shows this, the trend of the curve showing if it is a decreasing, then only we supposed to apply this particular method in order to estimate the population of that particular city or town. So then that's why it is this method is not a common one, and as population for each cities can be estimated using the other alternative methods like we discussed in the previous section. So here, if I take one problem for the in order to we'll do population forecasting according to decreased rate of growth method. So the problem says here very clearly, it is we need to estimate the population forecasting for 1980, 1990, and as well as 2000. So here this is total number of decays are here 3, nothing but 30 years. So this is the population for the last few decades. The last few decades data starting from 1940 and 1950, 1960, and as well as 1970. With respect to each year, you can see the population here. It is 8,000, 12,000, 17,000, and as well as 22,500 in 1970. So with this information, with this data, we need to calculate the population forecast for 1980, 1990, and as well as 2000 according to decreasing growth rate of the method. First, we need to be remember that in this method we need to be calculate the percentage increase between these decades, and then after we need to calculate the average of decreasing in the increasing the percentage. So then we'll see. This is our so this is a given problem. There you can see. First, we need to calculate the percentage of increasing. For example, you take some year here it is 1940. With respect to the 1940, the population is 8,000. Similarly, if it is 1950, the population is 12,000, and if it is 1960, the population is 17,000. Then in case of 1970, the population is 22,500. So this is our first step. In this, we need to calculate percentage of increase in population for this. So here we don't have any previous value for 1940, so that we won't get any. There is no scope to calculate the percentage of increase between the previous decade to the 1940. So here we won't get any value. The second case, here we are calculating for 1950. For 1950, there is a previous population, that is 8,000 for 1940. So see, very simple. We can here it is. The difference here it is. First, we need to calculate the increment. Here it is no value, and in this case it is difference is 4,000, whereas this case is difference is 5,000. And in this case the difference is 5,500. So now after getting this difference, now we need to calculate percentage of increment in population. So here it is already we have this increment value, and this is the base value for this, and it is equal to 4,000 divided by 8,000. Then we'll get we are calculating the percentage, so that's why it become, we need to multiply with 100. Then we'll get the percentage of increment in population. It is equal to 50%. Similarly for this one, so for this 1960, we have a previous value is 1950. Then in this case the difference here it is 5,000, and the previous population in 1950 it is 12,000. Then here we'll get 41.7, and then in this case the value of increment, percentage of increment is 32.4. So in this way we need to get, here I write directly. So here it is 50% and 41.7% percentage of increment in the between for these two successive decades. So then now we need to calculate according to our method. So here decrease in the percentage of increment. So now you see how much it is decreased. Decrease in the percentage of increment, for, as like in the previous case, we won't get any value for 1940. We need to calculate the difference in the percentage for this. So for 50 also we don't have any previous value, then we won't get any difference value here. But coming to 1960, our percentage of increment in population is 41.7. There is a previous value for the percentage of increment in population for 1950 it is 50. Then the difference value will get here 8.3. So positive. Similarly, the difference value here it is 9.3. So first we need to calculate the increment or increase in the population. Then after that, percentage of increase between two successive decays we need to be calculate. Then after, what is the decrease in the percentage of increase in population? That is the third step. After that, after getting this decrease in the population for each decays, then the next step is we need to calculate the total. We need to calculate the total. This total for in case of increment, it is equal to 14,500, and whereas here in this case you will not required, but decreasing the population, the total is equal to 17.6. So the average of this average value at here, average value is at this point 4833, whereas average value at this year 8.8. So these are the basic data to estimate the population according to the decreasing rate of method. So here, after getting these averages, again this is not at solid still. We need to estimate the population for 1980, 1990, 2000. After this, 1980, 1990 and 2000. We need to be estimate the population for this. So then, the very basic data we have the total decrease in the according to our method, the decrease in the percentage in population we calculated. Now, in order to estimate the population for 1980, is equal to population at 1980 is equal to. So this is the latest the previous one. As you can see, this method says that the latest percentage increase for each successive decade is we need to be work on it to get the percentage increase in the next decade. So the latest for this 1980 is 1970. So here it is, the percentage of increase in population is 32.4. What is the decrease in average? We need to be subtract. We need to be subtract from the latest percentage increase. So this average value is 8.8. Similarly, for 1990, again for 1990, the latest one becomes this answer. It is equal to 23.6. It is equal to 23.6. Again 23.6 minus 8.8, and it is equal to 14.8. And for 2000 year. For 2000 year, this 14.8 minus 8.8. This 8.8 is nothing but a decrease in percentage of population average value. So then here you will get 6. So this on and after getting these values, now to calculate the population in this particular 1980, population in 1990, population in 2000. So here the small calculation is required, that is it is simply like population plus the obtained value for each year, that is equal to, I will write directly here, the year population is 22,500, which is corresponding to 1970, and plus 23.6 divided by 100 into 22,500. So here we will get 27,000. Once after solving this one, here we will get 27,810. So this is the population in 1980. So this is the value, actually the latest one to the 1980. It is equal to 22,500. So then now for the latest one, as like this case, the latest one for 1990, the estimated population is 27,810. So one thing you may observe here, the difference between the previous methods to this method. In this method, whatever, for example, for n number of decades you are calculating the population, even though we in arithmetic method, in arithmetical increase method and incremental increase method, we considered the according to the census recorded data only as a previous. For all, for example, you are calculating in according to arithmetical method. Here we will consider this 22,500 only. But whereas this you say the decreasing rate of method, we are going to consider this is the latest one, this one, and this average we got, it is around 14.8, and then it is equal to, sorry, we need to be multiplied with the population. The latest one is 27,810. Now we will get the population in 1990. It is equal to 31,926. 31,926. And similarly, for this case, for 2000 population at 2000, it is the latest one. It become this one, 31,926 plus the average value is 6 year. Average from there we obtained, and it is equal to again 31,926. So the population at 2000 is equal to 33,842. So in this way we need to estimate the population according to the decreasing rate method. So I think it is very clear. I am moving to the next topic, that is master plan method. So here actually this master plan, the name itself, it is very clear. Master plan method. For example, if you consider Bangalore or Chennai or Hyderabad metropolitan cities, basically if the cities planned very well in advance for to accommodate the future population, densities. So for example, if you take Hyderabad, in Hyderabad, it is there is no proper planning so in that case, suppose if you use a master plan, in that case we can accommodate the densities, population density for n number of decades if you plan according to the master plan. So the reason why this the old existing cities were not planned, not planned according to the master plan is nothing but it's just then during that time they know these kind of studies and see here. That's why the most of the cities are developed in a haphazardous manner, irregular. There is no proper planning. So proper planning is nothing but, suppose if you plan the city in any city according to the master plan, there should be some industrial area, there should be some residential area, there should be some health point of view, there should be some health related. We need to be for example, if you have some hectares, if you have some land in square meter, some square kilometer, so then in that particular area we need to adjust for this is for the industry, and that particular area for the education, for that particular hospitality, for some particular area is for the residential. So like that. So this is even if you in future the population may increase, we can accommodate them by predicting the studies. By predicting the population, we can accommodate. We have a choice to look into whether we can accommodate the population in that in the allotted area. So in that case, so in master plan, we usually do the plan for the next 25 to 30 years. And according to the master plan, the city is divided into various zones. Those are like residential, commercial, and industry. So in other way also we can divide, but this master plan actually provides us to divide the entire area for this divide the entire area by keeping our mind like this, all these things. So for example, if you have some if you don't have any that kind of data, the population density are to be suggested according to the Central Public Health and Environmental Engineering Organization, as this manual provided some data. So you can observe here for the residential purposes, if the there are few categories in case of residential area, large lots of single family residences. The population density, number of persons per hectare is 10 to 40. So if it is small or single family residences, it is 40 to 90. Multiple family quarters are to be built on that particular area. There we need to be considered. We need to be accommodate minimum of 19 to 250 people. So if it is a tenement houses, like most of these kind of houses we'll see in US, so means nothing but the single room in a entire building. So it is in this case, if you are planning accommodate the population according to this according to the one, then we need to consider while calculating the population, it must be a 250 to 3500. So this is the actually we will get this data from this manual. And then in case of type of area, if it is a commercial one, so whatever the our town, actually we are, if you are planning in according to the master plan, as I told, in this method we need to be divide the entire area for industry purpose, hospitality purpose, residential, educational, and some other different purposes. So in that case, if it is a commercial area, if you are allotting some area as a commercial, then we need to be accommodate the population minimum density, population density, number of persons per hectare is 40 to 75. We need to be plan according to this. So industry case, it is 10 to 40, and whether if it is a park and a playgrounds, it is 25 to 125. So actually, in India presently we have two cities only planned according to the master plan. Those are Haryana and as well as Chandigarh. Haryana and as well as Chandigarh cities are planned according to this master plan. So if you plan any city according to this master plan, we can easily predict the population. If in future, if you consider other methods compared to other methods, we can easily predict the population using this method. So, but it is required. It required a predefined allotted areas for all kind of activities like residential purpose, commercial purpose, industry purpose, hospitality. So, and if you talk about entire world total, there are 2,700 cities are planned according to the master plan only. So in this case, we can easily expand the we can easily even if you plan according to the master plan, it will serve around 20 to 30 years without we can supply the water for this. We can consider design period like this, irrespective of calculating the design period separately. If we can easily calculate with this data instead of. So here the population densities are fixed for various zones in the master plan. These are the various zones. If you say these are the various zones, then the population density are fixed for various zones in the master plan. From this population density, the total water demand and wastewater generation, that easily we can easily calculate and we can easily estimate also. So here, so that's according to this method, it is very easy to assess precisely the design population. So while compared to the other methods, this master plan method is very useful and very easy to assess the design period and very easy to estimate the population for n decades. So this data you will get from this manual. And the next one is ratio method. It is very simple and very easy method. In this method, the local population of the country population, the local population and the country population for the last 4 to 5 decades is obtained from the census records. So here local population is nothing but suppose for example you are working in one state. Say for example you are working for instead of Andhra Pradesh. So for example you are calculating the population forecast especially for one town. Say you take the example of Vijayawada. You take example of Vijayawada. So this is one of the major town in Andhra Pradesh, and here the local population, according to this method, the local population is Vijayawada, and the country population is, you can say, Andhra Pradesh. So in these two, the local population and the country population for the last 4 to 5 decades to be obtained from the census records. So once if you refer the census data, there you will get data till 2011 for Andhra Pradesh, population data till 2000 for Andhra Pradesh. So then we will get the similar data for Vijayawada also. So then in order to perform this method, we need to be collect Vijayawada related population for last 4 to 5 decades and Andhra Pradesh related population last 4 to 5 decades. For example, if you want to calculate the ratio, if you want to apply this ratio method for Andhra Pradesh, then you can consider this Andhra Pradesh as a local population, and then the another one that is called country population. So if you want to do minor in this way, you can go. If you want to do majorly, you can go in this way. So here we are estimating the population for Vijayawada, and if you consider the country as your in this ratio method, then we are calculating the population for Andhra Pradesh. So the ratio of the local population to the national population have to be worked out. In between these two, we need to be calculate the ratio. Ratio of Vijayawada to ratio of Andhra Pradesh. We'll get some X value. For all 4 decades, we'll get some X1, X2, X3, X4 values. So a graph is then plotted, time and as well as the ratios. After getting this X1, X2, X3 are ratios, then we need to be plot a graph between population and as well as time. So we need to mark these ratios here. Then smoothly extend up to the design period. As we discussed in the previous method, that is in graphical method. So these are the known values. So you take 1, 2, 3, 4 as these are the known decades, and then smoothly we are extending this graph like this. So when time goes to our design period, so this is the maximum population according to this method. So then we need just to simply we are extended up to a design period. You say after 1990 our design period is this, till 1990 we have the data. If you have design period 30, then we need to extend this in this graph till 2030. So then after this ratio is then multiplied by the expected national population. In this case, we need to multiply with the national population at the end of the design period, so as to obtain the required city's future population. So this is very simple method. We need to consider any two state, for example, Hyderabad and Telangana, or Lucknow or UP. Then, as I said, Andhra Pradesh and Vijayawada. We need to calculate first. We need to calculate. We need to get the data from the census last 4 to 5 decades. Then we need to find out the ratio between them, and after getting some ratio value like x1, x2, the same ratio multiplied with the expected national population. So then after that we will get this population for the selected city or town. So then the accuracy of this method depends upon the national population estimation. So obviously, because we are multiplying with after getting these ratios, we are multiplying with the national population. Obviously, our answer is depending upon the accuracy of the national population only. And the method does not consider a abnormal or a special conditions which can lead to population shifts from one to another. Is obviously, because if you consider Vijayawada as we considered here, for the last 4 decades, we taken the census Vijayawada population from the census, but we are calculating for the next 5th and as well as 7th decade. There is a 30 years difference between here. So here, due to the people migrating for various purposes from Vijayawada to any other city, again here we don't have that migrated data, but we just consider the population during that time, and then we won't consider any kind of people shift from one city to another. So that's why it won't be preferred in normal way. So this ratio method, and the next one is logistic curve method. So this is very simple and very we will get some somewhat accurate value. This method is used when the growth rate of the population, if you have this data like due to birth, due to death and migrating take place under normal situations. Some municipal body has to maintain this data of that particular town or city, and it is not subjected to any extraordinary changes like epidemic, war, earthquake, and as well as any natural disasters. So we will consider only these, but we won't consider even though if you consider it is not possible to record that data, the increase or decrease in loss of population due to these events. So then the population follow the growth curve characteristics living things with limited in space and economic opportunity. If the population of the city is plotted with respect to the time curve, so obtain the under normal condition, like we will get in this logistic curve, we will get like the like this. So actually the logistic curve actually shows trend of the population of that particular city, trend of the population from starting to the ending. So here, for example, you see in this method it can be applied only whenever you observe some decreasing trend of that particular city. This then only we can apply this method. So then actually this is some S shape. So the logistic curve in F shape only. As you can see here, S shape curve and is known as a logistic curve. Now you see the way of estimating how we will estimate the population from using this logistic curve. Now you can observe here the trend of this. For example, you say this is for some city. The trend of that city population from starting. This is the starting point, and then this is the ending point. So here, uh, uh, this point, this is a S curve actually, S shaped curve. This showing completely trend, because here on horizontal axis we have time, and on vertical axis we have a population. Now you can see in the initial stage, uh, as you can see in the initial stage, the trend is quickly increasing. So here, population with respect to the time is directly proportional to the population. So whereas here you can see in this is a K, L and M. This is actually transition. This is the transition one. So here in this case, dp by dt equal to constant, like arithmetical increase method. So, and here see, after reaching some saturation level, where saturation is nothing but this city won't be accommodate more than these people. Whatever the population will get here, this city won't be accommodate more than. Now in the initial stage, as you can see the saturation difference here. As you can see, when the population reach to this level, this much only the saturation difference. So that to obtain that nothing but in this case we can say that the saturation of this particular city is not only depending upon the population growth, is also depending upon the area. So area, that is simply population S, PS. So this as you can see in this figure, this particular figure, this J and as well as N is shows complete trend of the population of that particular city. So then up to this J2K, there is a increasing trend. This J2K is a somewhat the rapid increasing in the population we can observe between J2 and K. And then this is the similar like a geometric growth. Then it is proportional to P, and then directly proportional to the P. And in the middle portion, nothing but from K to M. This is the middle portion. Here it is a it follow a arithmetic increase method. So that here in this case of arithmetical, we have some assumption, that is we will consider the constant between the population with respect to the time. So then the growth Mn, this one, the growth M to N, this is the final one. The growth M to N, the rate of change of population is proportional to the difference. The growth M to N, the rate of change of population to the difference between the saturation population and existing population. So that's why it is also not only directly proportional to the population, it is also with this area, where you can see according to this this form here, we need to calculate the population like this. So now you see, as I told, initially there is a rapid growth and there is a transition one, and then there is a final growth. So this is the value of saturation. So this is the saturation point of this for city. So it won't accommodate people more than this. So it becomes the growth of the population. It has to become here 0, because the city is not accommodating, because it is not planned according to the master plan method. So now these are the various formulas we need to work on it to get the population at saturated point, and then the population at M, where this is the transition one, the peak point M, and N is nothing but this one. N is the where the population growth is getting 0. There, what is the population? To calculate this one, you need to consider this one. So then now you see, we'll consider some problem. The data is given for 2010 and 2020. The population is 35,000 in 2010. The population is 78,000 in one, and in 2020 the population is 1,15,000. So these are the basic formulas we'll use, and it's very simple. Just only substituting here. First, here um, to calculate this, to perform estimate the population forecast according to the logistical method, we need to identify three data points. Those three data points are, you can say, like T0, T1, or T2. So, and the population with respect to this T0, T1, T2. So these T0, T1, T2 I am considering here. 2000 T0 as 2000. In this case, the population is 35,000. Whereas T1, the population is for T1 is nothing but for 2010 we are given to calculate, and it is 78,000. Whereas T2, it is 2020, so 1,15,000. So total 2000, 2010, 2020. So total T, we can say 30 years, or our design period is the given data is for the last 30 years. So then P1, P2 is nothing but the population with respect to the T0, T1, T2. So then now we need to to calculate the P. We need population at a saturation point. For example, you can consider at this point. For example, this you say we have P naught initial. At this Pk it is P1, and this point is say for example P2 also we estimated. Now at this point saturation we need to calculate the P3. So determine the saturation population and expected population in 2030. This is the question. We need to be calculated at this saturation point. This is the saturation point, and then what is the expected population in 2030. This is the design period. So now in order to calculate the population at saturation, then you can write here PS divided by it is equal to 1 plus M minus 3 into NT, where N is nothing but the maximum the city, or the maximum population can be accommodated by the city. That value is N, whereas T is nothing but the time period. So this M is the after transition, the final value at population at M. So in order to get this PS, we need to work out on this formula. So here you can see 2 into P0, P1, P2, because these are the populations. So whatever the values we have, this is a P0, P1, and as well as P2. So just if you substitute here, you will get 35,000 into 78,000 into 1,15,000. Then minus P1 square nothing but 35,000 whole square. P1 is nothing but 78,000 whole square, then into P0 35,000 plus 1,15,000 divided by 1,15,000 divided by again P0 P0 or P0 78 minus 78 whole square. Once you solve this equation, we will get the PS. This is PS is equal to 1,38,000 population. So then now we need to estimate this population at this transition point M. So here it is because in this formula we need M value and PS value. This is the M. So where M equal to P3 divided by P3 minus P0 divided by P0. So here P3 we obtained already. This is the saturation point as that is equal to 1,38,000 minus P naught is divided by again 35,000. So in this case, we'll get the M equal to 2.94. M equal to 2.94. Then next step is we need to calculate the for the design period. The design period is 2030. So N again if you substitute same values in if you substitute same values, we'll get N as a N equal to 0.261. If you substitute the P naught and PS, in case you can say P saturated value, PS, and this P here also P saturated is nothing but 1,38,000. You need to substitute here. Then after solving this, whereas T1 is nothing but 10 years, because you see this is the we are started from here. This is we consider as a T1. The difference here it is 10 years. So here we get 10 only. You won't get any 30, 40 like that. So then after substituting in our values, our population or T1, T2, T1 value here, then we will get N as this one. So now not yet completed. Now we need to be calculate. We need to be calculate this population at 2030. Population at 2030. Simply whatever the population we have, you just 1,38,000 we can write here. 1,38,000. 1,38,000. Then 1 place M into log root of minus c. N is nothing but the value which we obtained, that is equal to 0.261 and into 30. So here it is T0, T1, T2. So total 30 years we are calculating. So this become a to 30, and once after solving this equation you will get or else you can we need to work on some value here. If you take x is equal to log minus 3 0.261 into 30. So in this formula it becomes 230. So that is equal to 1,38,000 divided by M into X. Now if you calculate the X, if you obtain the X, then we will get the then we will get the population directly from here in this form, directly from this formula. So actually this method we can be used whenever you observe some decreasing growth rate of the particular city, and we will get some most accurate value in this method. So with this I am closing today's lecture, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.